Okay, so I'm here at the park and I'm going to be testing out the 6S Micro along with the Dark Knight Nirvana radio at the same time. Probably not the best idea, but when you're constrained with time, you gotta make do what you gotta do. Anyway, we'll see how things go. Hopefully I won't blow up anything and not crash, and we'll see if this thing performs pretty well or not. Okay, so I had to switch parks. A bunch of random people showed up, so couldn't fly over there. Flying a different park now. Okay, so it didn't blow up, and I can already feel the weight of the battery. Quite heavy. So the tune is just a default tune here. I did raise the TPA to 0.3, and doesn't sound like there's any issues with the motor sounding funny. They sound okay. I'm gonna land and just check the temperatures just in case. I don't want to fry the motor, but I don't think that's gonna be happening. So yeah, the motors are a little warm, but totally fine. I think it's going to be safe. So let's push this a little bit, see how it does. Yeah, wow. You can see not that much battery sag. 4 volts to 3.9 volts there. Let's try another one. For whatever reason, when I go full throttle, it only goes to like 83%. It's weird on the OSD. Try one more time here. Yeah, so I think it is the big advantage of the 6-cell LiPo is the battery sagging not as much as on a 4-cell. That's consistent with the reason why the 5-inch pilots like the bigger cells. Not as much voltage sag. And since I'm carrying 50% more energy and basically 2 more cells here than would fly normally on a 4-cell 550, I'm going to be getting probably 50% more flight time. So I'm not 100% sure if carrying this extra weight is really worth it. It does seem like it's fast, but hard to tell if it's really that much faster. It is, I think, if we look at the KV and everything, it is about maybe 5% faster. I'm not 100% sure. I'll have to do the math. Wait till the end of the video, I'll discuss it. But I'm just glad I didn't blow anything up. Overall, flies good. Smooth, pretty smooth actually. Yeah, it definitely has a lot of power, but I think if this were a high kV motor, I do have the same motor here, same style, 1306B, and a 4500 kV version. If I fly that on 4S, I think the RPMs of the prop are going to be higher. So that actually might end up being faster, although the amp draw is going to be way more. Probably have a couple more punch outs here. And I think it's, I don't want to kill the battery too much here. 3.6 volts, go ahead and land it, 22 volts total. Almost 5 minutes of flight time and a lot of punch outs. So, you know, less sag, probably better flight times on a 6L, but you're carrying around a lot of extra weight. Probably be better to go to a smaller 6L, like a 400 or maybe 450. But I don't think anyone makes those. That's the problem. Okay, so before I get into the technical aspects of this demo flight, just want to talk about the transmitter first here, and it worked out fine. Gimbals were fine. I had no fail safes or dropouts or anything like that. It worked as I expected it to. Now the firmware that's on here, which is the underground FPV firmware, it's one of the beta versions, did not have RSSI working for the receiver, and this is their diversity receiver, so I had two antennas here. And usually this type of diversity receiver, which is similar to the X6B receiver, you should be able to get RSSI via telemetry. However, I wasn't able to figure out how to get that to work, so I'm going to have to look into that and see why that wasn't working or why that isn't a function of the firmware yet. So it's possible that they might not have put that in at this time. So yeah, obviously it's still beta firmware, but I didn't have any fail-safes or dropouts. It seemed to be fine, performed fine. Obviously getting used to the weight of this radio is, you know, something for me a bit of a challenge because I'm used to carrying lighter waders like the Jumper T12. Gimbals are very smooth and loose, like the way I like. Reminds me a lot of the way the Evolution gimbals feel, but even smoother and actually better. I had no problems with control or precision. Everything was perfectly fine in terms of the transmitter. So so far so good. I'll have to see if the firmware improves, and I'll have another video, of course, down the road after some more updates come, and so you'll have to look out for those videos later. Okay, so now the performance of this in terms of, you know, this being a 6S setup, obviously with the Emax, this is the Mini Magnum F4, it is 6S capable, of course, which is I was running the 6S battery and this 2700 kV motor. I think like certain things I expected to happen did happen, and certain things did not. I thought maybe it would be a little bit faster, but then again, it was carrying around a lot of extra weight with the bigger giant 6S LiPo, and I'll give you some weights here to give you a little bit of perspective of what's going on. The kV of the motor here is running the prop at about the same speed as this motor. This would run on a 4S LiPo, on a 4S setup, at 4,000 kV for this motor. So if you probably remember, I think Emax made a 1306, like a regular with a 5mm shaft, a 4,000 kV motor, and obviously a different prop, a bit more heavier prop with the bigger nut and everything, and the bigger shaft. But that kV would be pretty similar in terms of RPMs for a 3-inch prop, and I remember what that kind of felt like and that kind of speed. But I did also remember that on 4S, when you would hold those punch outs for a little longer, the battery would sag pretty much right away, and then it would actually slow down, so you wouldn't actually be able to maintain those RPMs for very long compared to what you saw with the 6S LiPo. So it's kind of a trade-off. It accelerates a little bit slower, but then it's able to maintain that top end speed a little bit more at that RPM. Now I do have another motor, same 1306B motor here, but this one is a 4,500 kV, so you guys can see that. Yeah, it comes into focus here. Yeah, it's a 4,500 kV, not a 4,000 kV. So I'm going to actually try this test again later. I'm going to swap these motors out and run this on a 4S setup, and this prop will actually run a lot faster. And let me just show you what I got to show you some math here to explain the numbers. So what we tested today, 6S, you know, the maximum voltage 25.2 volts times the kV gives you a prop RPM of 68,040. And then if you run a 4S LiPo on a 4,000 kV motor, your maximum RPM is 67,200. So it's actually a little bit less compared to this, but pretty in this kind of same ballpark. Now if I try to run 4S on this 4,500 kV motor that I'm going to swap out next time, the RPMs goes up to about 75,600. So I should be able to get the prop to spin faster at the top end, but I'm thinking at this KVM Forest and the lipo sag that we're going to see, when you compare it to the 6S, it'll be fast and then it'll start to slow down. So I'll try and do it at the same park that I flew it for that test. I suspect that the speed isn't going to be maintained for the length of that field that I was flying at. So something I think that's what's going to happen when I fly it on Forest on this motor. So we'll have to see if that pans out or not. But kind of what I expected for this is what I thought would happen. I thought it would be similar to a 4000 kV in terms of the speed, but it did seem like it was able to maintain that top RPM for longer going down the park. So something that I think that's what 6S will do. But I think, you know, we're carrying around a lot of extra weight. So let me just show you this. At the beginning of the flight I was kind of saying it felt heavy, and it did feel really heavy. This drone, so the drone weighs 125 grams and the battery weighs 107 grams. So the battery weighs almost as much as the whole drone, and you can feel it when you're flying around. Now, I normally would fly this 550 4S. You can see that it's a 4-cell, so it's actually the same company, same packs are the same, internal packs are the same size. You just have 2 more of them on the 6-cell versus a 4-cell. This one is, you know, obviously it's going to weigh 50% less at 71.4 grams, 71.5 grams. So obviously the total weight is going to be way less. So we'll just put this together here. Run around Forest, total weight's going to be 196.5 grams. And the flying weight of this on 6S is coming in at 232 grams. So you definitely felt that extra, I guess it's about 35 grams extra weight flying it around. Mostly when you drop the throttle a little bit and or kind of making little maneuvers, you would feel the weight drag this thing down quicker because of the extra weight. So that's I guess that's the disadvantage of flying with the bigger 6-cell 550 versus the 4-cell 550. So I'm thinking, you know, the solution obviously would be to get a battery that's a 6-cell that weighs about the same as this 550. So that would probably be in the ballpark of like a 350 to 400 milliamp hour 6-cell, but I don't know anyone that makes a 6-cell 350 or 400 milliamp hour LiPo. So, and then the other thing is when you reduce the overall capacity of the battery, then you're going to get actually more sag out of the battery because it's a smaller battery compared to what it was before when you're flying a bigger battery. Bigger battery can hold the voltage for longer versus a smaller size battery. So even if I did go to a smaller 350 6-cell, I have a funny feeling that the sag might be similar to this 4-cell 550. So, I mean, I have no way of testing it because I don't have that kind of battery, but that's my suspicion. And I think that if you want to be, I think that's what the advantage of the 6-cell is that you have the bigger battery, more overall energy capacity, so you're gonna have a better, like a longer flight time. Obviously, you know, it's just 50% more energy going from, you know, 4 cells to 6 cells, so you should get more battery life, and then the current is going to be spread out over 2 more cells versus 4 versus 6, so it makes sense that you're going to have less voltage sag because it's the energy that's being sucked out of the battery is spread out over more cells. So that's the theory of 6-cell versus 4-cell, and in a lot of the ways, the way it works for 5-inch kind of works the same way for 3-inch. When I was going from the 4 cells on the 5-inch to the 6 cells on the 5-inch, kind of had a similar experience. It wasn't like it was that much faster. It's just that when you had long punch outs, it would maintain that speed a little bit longer and the battery wouldn't sag as much, and the battery would maintain its voltage more consistently throughout the entire flight versus when you have a 4-cell, like about halfway through the pack, you get a lot more battery sag, and you don't have as much performance compared to the 6-cell. So that's really, I think, you know, a lot of the similar things that happened on the bigger 5-inch pretty much happened on the same 3-inch here. It didn't really go that much faster. So I think what would be more interesting is instead of this 2700 kV motor, I think what I'll try is the 3100 kV motor. So well, actually, Emax doesn't make a 3100. They make a 3300 kV motor. So that might be pretty insane if I ran the 3300 kV motor on 6L, because then, of course, at that point, because of the higher kV, the prop is going to be going way faster, and then you'll have the advantage of being on a bigger 6L. Obviously, you still have to deal with extra weight and everything, but at that point, it ought to be pretty interesting what could happen, assuming that the 3300 kV motor can handle 6S. That, I don't know. Now, obviously people were worried that the 2700 kV motor might not be able to handle 6S. It had no problems at all. It did run a little bit warm, but that was expected. It was actually not even that warm, to be totally honest. It was completely fine after all those punch outs and everything in the flight. So I'll have to find out, see if the 3300 kV motor could take 6S or not. I'll have to see. If after, I think I'll do the 4500 kV motor first, test that out in 4S, compare, and then maybe I'll come back to this and maybe try a 6L with a higher kV, like 3300 kV. Anyway, so that's the conclusion for this test here. Thought it was interesting. Anyway, I hope you found this video helpful. Now, I'm not 100% sure how practical 6S is going to be on 3-inch in the long term. I thought this was kind of a fun experiment. Let me know what you guys think of these kind of little experiments for the future. I might do some more of these kind of things, just test stuff out. Obviously, like things like, people are asking me, are they going to be making these motors and stuff like that? I don't know. These are prototypes, so they may or they may not. And in terms of like when they're coming out or what price they're going to be at, I have no knowledge of that information. So sorry. Even if I did know, I don't think they would let me tell you anyway. This is just for testing purposes, and just wanted to use this equipment to sort of just do these kind of experiments and get a little more knowledge out there on whether or not 6L would be practical for a 3-inch setup or not. So I think the jury's still out. I'm going to do some more testing in the future, and we'll see. So let me know if you have any comments or questions down below, and I'll talk to you guys in the next one.